Assalamu alaikum students, hope you all will be fine. Today our topic is De Morgan's law. Augustus De Morgan was a British mathematician who lived during 18th century. He developed two important laws used in sets. The first law is A union B complement is equal to A complement intersection B complement. Similarly, second A intersection B complement is equal to A complement union B complement. To prove the De Morgan's law, we have three sets. First is universal set, which is 2, 4, 6, 10, 12, 14, and the second, which is A, 2, 6, 10, 12. Set B is 6, 10, 12, 14. Now we are going to prove the law. Left hand side we have A union B complement. So firstly we find the union of A and B. A is 2, 6, 10, 12, union B 6, 10, 12, 14. Union means we combine the values of set A and B. Then we have 2, 6, 10, 12, 14. Then we find complement. It means that we subtract A union B from universal set. Universal set we have 2, 4, 6, 10, 12, 14 minus A union B we have this, which is 2, 6, 10, 12, 14. Now we write the value which is present in only universal set, not in A union B. So only we have 4 which is present in universal set, not in A union B. Now right hand side we have A complement intersection B complement. For this we find the A complement, then B complement, then the intersection of both A complement and B complement. So we subtract A from universal set. Universal set we have 2, 4, 6, 10, 12, 14 minus A we have 2, 6, 10, 12. Now we subtract A from universal set, so only 4 and 14 are present in universal set, not in A. So this is the A complement. Similarly, B subtract from universal set 2, 4, 6, 10, 12, 14 minus B is 6, 10, 12, 14. And the answer is 2, 4 because 2, 4 is not present in B. So this is a complement. Now we take intersection of A complement and B complement. A complement we have 4, 14, intersection B complement we have 2, 4, and the common in both set is 4, so A complement intersection B complement is 4. Now we see that left hand side equals to right hand side. It means that we proved A union B complement is equal to A complement intersection B complement. Similarly, second law we have A intersection B complement is equal to A complement union B complement. If we take the left hand side, which is A intersection B complement, A intersection B, A we have 2, 6, 10, 12, intersection B we have 6, 10, 12, 14. Intersection means we write the common value from the A and B, which are 6, 10 and 12. Similarly, we subtract A intersection B from universal set to get A intersection B complement. So universal set is 2, 4, 6, 10, 12, 14 minus A intersection B, which is 6, 10, 12. Now we write the values which are present in universal set, not in A intersection B. So we have 2, 4, 14. Right hand side, which is A complement union B complement. A complement means U minus A. U 2, 4, 6, 10, 12, 14 minus A 2, 6, 10, 12, and we get 4 and 14. Similarly, B complement U minus B, we get 2, 4. Now we take union of A complement and B complement. Union means we combine the both elements of set A complement and B complement. Now we get 2, 4, 14. So we see that the left hand side is equal to the right hand side. It means that A intersection B complement is equal to A complement
union
B complement. So De Morgan's law is proved. Now we solve question number 8. If universal set is equal to 1, 2, 3, 4, 5, A is equal to 1, 3, B is equal to 2, 4, C is equal to 5, then we find the values. According to question number 8, the first part it is A union B intersection C. A union B means we solve bracket. To find A union B, we write the value of A union B, then it means that we combine the both element of the set, we get 1, 2, 3, 4. Then A union B bracket intersection C means we find the intersection with C. So A union B is 1, 2, 3, 4. Intersection B we have 5. There is no common value in the both sets, so we have an empty set. Now we draw the Venn diagram. For the Venn diagram, the horizontal lines shows A union B and the double lines shows intersection C. The common values from A, B we write here, B, C we write here, A, C we write here. There is no common value, so this region was empty. So this region is empty and there is no common value in A, B, C, so this region is also empty. Next we have A intersection B bracket union C. A intersection B, firstly we find A intersection B. A is 1, 2, 3, 4, 5. Intersection B is 2, 4. A intersection B is equal to 2, 4 because in intersection we write the common value. Then A intersection B union C means we take union of A intersection B and C. A intersection B is 2, 4. Union C we have 5. A intersection B union C we get 2, 4, 5. Now we draw the Venn diagram. We have A intersection B in bracket. So A intersection B means this region, which is shown with horizontal lines. Then union C, and union C is represented by the vertical lines. We have 2, 4, which is common value in set A and B, and remaining we have no common value, so this and this region is empty. Next question we have A union bracket B intersection C. Firstly we find the B intersection C. B we have 2, 4. Then intersection C we have 5. There is no common value, so we have an empty set. Then we take union of B intersection C with A. So A is equal to 1, 2, 3, 4, 5. Union B intersection C we have an empty set. So when we take union, we combine the both values from the set A and B intersection C. So we get 1, 2, 3, 4, 5. And now we draw the Venn diagram. We see the bracket which is B intersection C. B intersection C is showing by the horizontal lines and union A is showing with the vertical lines. 2, 4 is a common value in set A, B, and remaining there is no common value, so this region is remaining empty. Question number 8, next part we have C part, which is union B complement is equal to A intersection B complement. And the next we have A complement intersection B complement is equal to A union B complement. We solve left hand side, which is A complement union B complement. For A complement we subtract A from universal set and we have 2, 4, 5 because we write the values which are present in universal set, not in A. Similarly, we subtract B from universal set and get B complement, and we have 1, 3, 5 which are not present in set B. So we have A complement is equal to 2, 4, 5 and B complement is equal to 1, 3, 5. Now we take union of the both A complement and B complement. The union is 1, 2, 3, 4, 5 because in union we combine the values from the both set. Right hand side we have A intersection B complement. It means firstly we solve bracket, now we take A intersection B. A intersection B, A we have 1, 3, intersection B we have 2, 4. There is no common value, so we have an empty set. Then we subtract A intersection B from universal set to get complement of A intersection B. And we have 1, 2, 3, 4, 5 universal set minus A intersection B, which is an empty set. And when we write the values which are present in universal set, then all the values are present in universal set because A intersection B is an empty set. So we have 1, 2, 3, 4, 5, and left hand side is equal to the right hand side, which is A complement union B complement is equal to A intersection B complement. Similarly, next we have A complement intersection B complement is equal to A union B complement.
Left hand side, for the left hand side
We find the A complement and B complement, then we find intersection of the both set. U minus A is equal to A complement, so we have 2, 4, 5 which are present in universal set, not in A. Similarly, U minus B, we have B complement 1, 3, 5 because 1, 3, 5 are present in universal set, not in set B. And now we take intersection of A complement and B complement. Intersection means we write the common value, so we have a common value 5 which is present in both set. Right hand side we have A union B complement. It means that we find the union of A and B, then we subtract A union B from universal set. A union B we have 1, 2, 3, 4. Next we subtract A union B from universal set. Universal set is 1, 2, 3, 4, 5 minus A union B is equal to 1, 2, 3, 4. A union B complement means we write the value which is not present in A union B. So only the 5 which is not present in A union B. It means that A union B complement is 5. So we can see that the left hand side is equal to right hand side. So A complement intersection B complement is equal to A union B complement. Next question, question number 12. If A is equal to MNO and B is equal to PQRS and C is equal to NOPQ, prove the associative property of intersection of sets. Associative property of union is A union bracket B union C is equal to A union B bracket union C. You can see the difference. Here bracket is on B union C and here the bracket is on A union B. Left hand side we have A union B union C in bracket and then B union C because we solve bracket, so B is PQRS union C is equal to NOPQ and the union of the both set NOPQRS. Now A union bracket B union C, A we have MNO, union B union C we have NOPQRS and the union of the both set is MNOPQRS. Right hand side A union B bracket union C. Firstly we solve bracket A union B, which is A is MNO, union B is PQRS and the union of the both set is MNOPQRS. Now union with C, C is NOPQ and the union of the both set is MNOPQRS. We can see that the left hand side is equal to the right hand side, so associative property of union is proved. Next question we have multiple choice. Question number 1, select the correct answer from the given option. The first statement we have, if universal set is equal to 2, 4, 6, 8, 10, 12, 14, which is a subset of universal set. Subset means set from universal set. So if we see 2, 4 is include universal set, so A is a subset of universal set. A is equal to 1, 1 is not an element of universal sets. Similarly, A is equal to 1, 3, 5, 7, which are not the element of universal set. B, 2, 3, 4, which also not the elements of set U or universal set. Next, which of the following is the largest set? Set of the even number, set of the odd number, set of the whole number, set of the integers. The correct answer is set of the integers, because integers includes positive and negative whole numbers starting from 0. How many subset does the set A is equal to 1, 2, 3, 4? According to the formula 2n, and we have 4 elements of set A. So we write 4 in the place of n, then 2 multiply 2 multiply 2, which is at 2 power 4 is equal to 16. It means that when we make the subset of set A, we have 16 subset. Which of these is a proper subset of A is equal to 1, 3, 5, 7? Proper subset mean all of the elements are present in set B, but at least one element is not present in set B. Here we see B is equal to 1, 2, 3, which are not the element of set A. 1, 3, 5, 7, which are all the elements of set B. So this is not a proper subset. Next, B is 1, 3, 5. 1, 3, 5 is the correct answer, because only one element which is not present in set B. So the correct answer is option C. Which of these is the correct statement for the De Morgan's law? A union B complement is equal to A complement union B complement. Both sides we have union, so this is wrong option. Similarly, here we see that both sides have intersection.